Section 4.3, solving nonlinear systems of equations. In the previous sections, we used 3 methods to solve linear systems. In this section, we will use the same methods to solve nonlinear systems. So a system of nonlinear equations is a collection of 2 or more equations in which at least one equation is not linear. A solution of a system of nonlinear equations in 2 variables is an ordered pair or a set of ordered pairs that satisfies each equation in the system. Let's take a look at example 1. Determine if the given points are solutions to the following system. So they're giving us different ordered pairs, and we need to plug them in both my equations to see if it satisfies them. So don't forget this is x comma y. So let's go ahead and check the first point. So we have 1 squared minus 1 equals 0. 1 squared is 1 times 1. Minus 1 is 0. 0 equals 0. Yes. We need to check for the second equation as well. So 1 plus 1 equals 2. 2 equals 2. Yes. So that means that this point is a solution. Let's take a look at B. 0 squared minus 2 equal to 0. 0 squared is 0 minus 2. Minus 2 equal to 0. No. So this is not a solution. And the last one, we have negative 2 comma 4. So we have negative 2 squared minus 4 equals 0. Negative 2 squared is negative 2 times negative 2, 4. So 4 minus 4 equal to 0. 0 equal to 0. Yes, let's check for the second one. We have x plus y equals to 2. So we have negative 2 plus 4 equals to 2. Negative 2 plus 4 is 2 equal to 2. Yes, so this is also a solution. For the graphical method, to find the solution, we need to graph each equation on the same Cartesian plane and find the point of intersection. So the intersection or intersections are the solutions to the system. Once we find them, we need to check them. So for example 1, where my lines are intersecting, that's going to be my solution. So they're intersecting here. And that point is negative 2 comma 4. And they're also intersecting here. And that point is 1 comma 1. So let's go ahead and check those solutions. So check. We have y equals 2x squared. We're going to check the first one. We have negative 2 comma 4. So we have 4 equals to negative 2 squared. 4 equals to 4. Yes. Check on the other equation, which is x plus y equals to 2. So we have negative 2 plus 4 equals to 2. 2 equals to 2. Correct. Now let's check the other point. So the other point is 1 comma 1. So for my first equation, I have y equals to x squared. So I have 1 equals to 1 squared. 1 equals 1. Yes. And the second equation, we have x plus y equals to 2. So 1 plus 1 equal to 2. 2 equal to 2. Correct. So my solutions are negative 2 comma 4 and 1 comma 1. For example B, my graphs are intersecting right here. So that's negative 1 comma 0. And they're intersecting over here, 1 comma 0. Let's go ahead and check those points. So we check. Let's check negative 1 comma 0. So we have y equals x squared minus 1. So we have 0 equals negative 1 squared minus 1. 0 equals negative 1 times negative 1 is positive 1 minus 1, 0. That checks. And then on the second one, we have 0 equals negative 1 squared plus 1. 0 equals negative 1 times negative 1 is positive 1, but we have this negative outside. So that leaves us with negative 1 plus 1. So 0 equal to 0. Yes. So that point is correct. Let's check the other point. The other point is 1 comma 0. So we have 0 equals 1 squared minus 1. 0 equals 1 squared minus 1 is 0. So it's correct. For the second one, we have 0 equals negative 1 squared plus 1. So 0 equal to 0, correct. So my solutions are negative 1 comma 0 and 1 comma 0. For example 3, find the solution or solutions to each system below if it exists. If you notice on example A, my graphs are not intersecting. So that means that there is no solution here. So there is no solutions. So no solutions. The graphs do not intersect. The graphs do not intersect. For the second example, if you notice, our solutions are already pointed out, which is this one and this one. So those two are gonna be my solutions. So solutions negative 0.712, comma, negative 1.869, and 1.704, comma, 1.046.